So in this video, we're going to be calculating or giving out how or demonstrate how you can find the special angles of cos 90, cos 180, cos 270. All those things you have here are also special angles. And we're going to start by showing how you can find cos 90 and all the special angles that we have on this upper section. And to do that, I have a cosine graph on the board. So the reason why I didn't fill up or label it properly is so that I can explain how we got it and how you can also use it, because if you can understand how this applies to this, it is easier to remember rather than just taking it in that way. So you have a cosine graph, and this that I've drawn here is more like a sinusoidal graph. It is a wave. This is in a waveform, and this from here to this place is what we call a wavelength. That's if you have seen, if you've done physics, you understand what I mean by wavelength. But if you're not, if you don't do physics, just know that from this point to the point it moves and returns back to the same point is what we call a wavelength. So when it travels for a complete wavelength, you can say it has traveled 360 degrees complete. And if that is the case, if I should divide this wavelength into 4 equal halves, then I'll have 90, 90, 90, and 90. So that's what I'm about to do. Splitting this 360 into 4 equal halves, then I have this point, which is the middle, must take the value of 180. So here is 360. And then if that is true, that means if I should split it, here must take the value of 270, and this must take the value of 90. So we're progressing. From this point to this point is 180, 360, 270, 360, and then this one must be 360 plus 90 for me to find this guy here. 360 plus 90, which is 450. So in this case, let's now find what sine cos 90 would be. Cos 90, so cos 90 is on this side, on the 0 level. So cos 90 is equal to 0. Cos 270 is also on the line of 0, while cos 360 is hitting the upper region, which is 1. So cos 360 in this case must be 1. Cos 450 is on 0. So I hope you understand how this pattern works. It's more like a pattern. For me to also find the next one is going to hit on -1. If I'm interested to find what cos 540 would be, you see, it's actually hitting, it's going to be on -1, right? So it's just a pattern, a sinusoidal graph of the cos graph. So the only way you're going to differentiate this with that of the sine is that it's starting from 1 and then moves. So in this case, we have the sine graph, and let me quickly explain how the sine graph works and how you can use it to determine the special angles. When you see 1, you just know what to do. So in this case, this is the sine graph starts from 0, and the wavelength, once it returns back to 0, right? You see, this way, moving upwards and also returning upwards back to this point becomes our 360, right? And then if I should split 360 into 2, at the midpoint here must be our 180, and then this must be our 90, And half of this wavelength will also give us 90. And 180 plus 90 will give you 270. So we're here. And then if I also should proceed, I will have here to be 450 degrees. Now in this case, sine 90, can you see the sine 90 is hitting on this point? So sine 90 will always be 1 as long as we're on degree, right? Sine 180 is hitting on 0. So once I see sine 180, I'll just go straight ahead and impute 0. And then sine 270 is hitting on -1. And sine 360 is hitting on 0. And then sine 450 is on 1 again. So this is actually how it works, and so on, depending on what you're required to find, right? So in this case, I can as well find what sine, say 720 would be, because sine 720, when it moves, it will also have to return to this point, and I'll know that sine 720 will give me 0, right? So this is just a graph. So the best way to remember this is to remember this graph. That is how I remember it, right? Just know that it moves from 0 for sine, it moves from 0, and then observe the rule. As long as it continues, the upper region for this, in this case, will be 1 and -1, and then so on. Once you can draw this graph correctly, be it from your memory or on a piece of paper, it becomes easier for you to pick the special angles that and relate it accordingly. So thanks for watching.